Okay, so the last type of variation is called standard deviation. And again, this is very, very important. This is the type of variation we'll use mostly this year. So I'm going to put stars next to it, okay? So what is standard deviation? Well, standard deviation is the typical distance values are from the mean. Notice that it says mean, right? So if you're going to use the mean as your center, then you should use standard deviation as your measure of variation. Now, typically, I like to call standard deviation STD. I understand that STD stands for something else, but we're going to let it be standard deviation in this class. Okay. So this is the big formula. So if the data contains these x values, these sample values, right, we can use this formula Sx equals, and it's a big long square root thing. Again, I don't care that you need to know this. We're not going to do it by hand. We'll let a calculator do it for us. But this Sx, just remember that this is called the sample standard deviation. Sample standard deviation. So get used to the notation, right? And start practicing, because as we go through this class, we'll use that a lot more. Okay, so a couple properties here of standard deviation. First, it's always greater than or equal to 0. It's a distance, right? Again, it's the typical distance from the mean. So even if it's below the mean, so it's less than the mean, don't think of it as a negative value. Think of it as a positive distance. Next, larger values of the sample standard deviation indicate greater variation. And this should make sense, right? If the standard deviation is large, then that means your data varies more or greater. Next, the standard deviation is not resistant. It's not resistant. Again, it's related to the mean, right? If you look at the formula, it involves every single value in the data set. So even the big ones and the small ones that could be outliers are going to affect the standard deviation. And last but not least, it measures the variation about the mean. Again, it is related to the mean. So if you use the mean, you use the standard deviation and vice versa. Sorry about that. Let's erase the writings. Okay, so last but not least here, this kind of ties into section 1.6. We talked about choosing the median or the mean as your center. So now, how do we choose the center and the variability? Well, number one, if it is skewed either right or left or has outliers, that's where you use the median and the IQR. And again, remember, they are resistant to outliers. So that's why you use these two values for the center and variability. If you are roughly symmetric with no outliers, so you're more of a bell-shaped curve, like we'll do a lot in the future, we're going to use the mean and the standard deviation. So again, remember x bar is the sample mean, and Sx is the sample standard deviation. So again, try to link these two things together: the median IQR and the mean and standard deviation. Okay, so last example here, it says, how many pets? 9 children were asked how many pets they had. Here are the responses, arranged from lowest to highest along with a dot plot. Now I need to edit this because I did not arrange them lowest to highest. Okay, sorry about that. So the dot plot shows the responses, and here it is. Okay, so calculate the standard deviation and interpret this value in context. Well, I'm going to take a picture of this data real fast because I'm going to have to enter it into the stats applet. Okay, so I'm going away here. Let me get the stats applet. This is one quantitative variable. So we're going there. I don't care what the variable name is right now. So my data, if I look at the picture, there was 1, 1, 1, 3. There were 3 4s. There was 1, 5, 1, 7, 1, 8, and 1, 9. 9 data. Who has 9 pets, by the way? That's crazy, crazy a lot. So there's that dot plot again. Here is our summary statistics. When we're talking about standard deviation and its interpretation, we have to write down the mean and the standard deviation. So the mean is 5, the standard deviation is 2.55. So I go back to my slides here. So the mean, so x bar was 5, and the standard deviation, the sample standard deviation, Sx was 2.55. So again, let's talk about what these mean, right? And again, the label would be pets, right? So the mean is 5 pets, and the standard deviation is 2.55 pets. So there's your standard deviation. So think about this. They're telling you that 5 is the mean. So I'm going to put this right here. This is your x bar. So This is not exactly correct, but this is how I think about standard deviation. So if I measured how far all the other dots were from 5. So first of all, this dot is 0 away from 5 because it's 5, right? So that's a 0. That distance is 0. But then these three each have a distance of 1. This dot has a distance of 2, and this dot has a distance of 1, 2, 3, 4 from 5. Over here, this dot has a distance of 2, this dot a distance of 3, and this dot a distance of 4. So all of those distances, I think of the standard deviation as if you took those distances and you averaged them. It's not exactly correct based off the formula, but again, it's a good kind of approximation. So if you average those distances, that could be considered something like the standard deviation. Okay. And now let's interpret this. So our interpretation is going to look like this. We're going to say the number of pets. You could write the word number out or use the hashtag, the number of pets. So that's our variable. And then here comes our standard deviation words. Typically varies. That's the words. If you ever have to interpret the standard deviation, you better have typically varies, and then we talk about the standard deviation by 2.55 from the mean of 5. Typically varies by 2.55 from the mean of 5. Now, if I were uh, if I were collecting data that had labels like units, so for inches, so for instance, inches or feet or like liters, I would put those with these numbers. But because we're talking about pets, I already said it here, so I don't have to say it again, right? So 2.55 pets from the mean of 5 pets. That's redundant. Okay. All right. Very good. All right. So have fun with your homework.